Geometric Optics 5, Refraction. Refraction is when light slows down and bends as it travels from one medium to another. You can see this with a simple experiment. Place a pencil in a beaker of water. As you can see, the light coming from the pencil bends as it travels or as it changes medium. So it goes from air to water. So it's changing medium. And as you can see, the image actually bends. So it appears as if there's two pencils or if there's two different images. Now, when it slows down, so when light slows down, it bends toward the normal. When it speeds up, it bends away. I'll define what normal is in a second, but just remember, when it slows down, it bends toward the normal, and when it speeds up, it bends away. Now, index of refraction, N, is a measure of how fast light travels and how much it bends when traveling in a medium. The higher the index of refraction, the slower and more light bends toward the normal. So the higher the N value, okay, the slower light travels. Now, let's diagram this out. So let's say I have two mediums. Okay, I have air and I have water. Okay, this is my boundary. Now, I have my normal line, which is perpendicular to the boundary. And then I have my incident ray. So I have an incident ray entering at some angle, let's say 45 degrees. Okay, this is my incident ray. Now, my refracted ray is the ray of light that is refracted or bends when it changes medium. So as the light ray changes from air to water, it will slow down and it will bend toward the normal. Okay, so here it's the refracted ray. So we call this the refracted ray. Now, the boundary, again, is the border where the medium changes, so between air and water. And then we also have the normal line, which I stated above, the line perpendicular to the boundary. And then finally, we have the angle of refraction. So this is the angle of incidence. That's 45 degrees. And then we have some angle of refraction. And we don't know what that is. And that's the angle between the refracted ray and the normal. Now let's look at two different equations. Our first equation is an equation that relates the index of refraction with the speed of light. So let's say I have an incident ray in a vacuum, and then it changes medium and enters into a different medium. Okay, so N is my index of refraction for that medium. So this has some value of N. And then C is the speed of light in a vacuum, which is 3.00 times 10 to the 8th meters per second. V, on the other hand, is the speed of light in the new medium. So what is the new speed? Okay, so N is really a measure of the ratio between the speed of light in a vacuum and the speed of light in a different medium. Every different substance has a different value of N. In addition, we have the next equation, Snell's law. Snell's law takes a look at the actual angle measurements and the different angles of refraction. So Ni is the index of refraction for the first medium, so I'll call this medium 1. Okay, and then I have medium 2, water. So Ni is going to be the index of refraction for air, and then Nr is going to be the index of refraction for the second medium. In addition, I have theta I, which is the angle of incidence, okay, and that's this angle here, and then I have theta r, which is the angle of refraction. This is a very important equation to determine either the index of refraction, the indices of refraction, or the angles of incidence or refraction.